3.2, solving systems algebraically. In this case, we want to talk about using substitution. So remember, substitution, the key is to solve one equation for a variable and then plug what that variable equals in for itself into the other equation, then solve. When you've got a solution for one variable's value, you plug it back in to find the other. Another thing, you should remember this from Algebra 1, but if not, hopefully this is a quick refresher. So here, we're going to try using substitution. The key to using substitution means you first have to have a variable solved for. The easiest variable I can think of to solve for in this case would be x. So I'm going to get x by itself. So I've got x plus 3y equals 5. I'm going to move the 3y over by subtracting it. So x equals negative 3y plus 5. So now that I know this is what x equals in terms of everything else, I can take this value and plug it in for x here. So this is going to become negative 2 times negative 3y plus 5 minus 4y equals negative 5. Now I just use my algebra skills to solve this. So I'll distribute 6y minus 10 minus 4y equals negative 5. Combine like terms, 2y minus 10 equals negative 5. Add 10 over, you've got 2y equals 5. Divide by 2, y equals 2.5. Now that we know what y is, we can plug this back in to this expression in order to figure out what x truly is. So now we're going to get x equals negative 3 times 2.5 plus 5. Well, that's x equals negative 7.5 plus 5. So x is going to be equal to negative 2.5. So our solution in this case is negative 2.5 comma 2.5. Here we have a substitution word problem. So in this case, an online music company offers 5 downloads for $19.75, 40 downloads for $43.50. Each price includes the same one-time registration fee. What is the cost of each download and the registration fee? So we don't know the registration fee, so we're going to let that be, we can just let it be F. And then we know we're buying downloads, so we can let those be D. So we're just going to write 2 equations. We know one case we've got 15 downloads plus the registration fee equals $19.75. In the other case, we've got 40 downloads plus the registration fee equals $43.50. First step should be to solve one of these for f. I'm going to rewrite this one in terms of f. So f equals negative 15d plus 1975. Now that I know what f is, I'm going to take this value and I'm going to plug it in here. So that's 40d minus 15d plus 1975 equals 43.50. Combine like terms. I'll combine like terms. We've got 25d equals, and I'm going to move over the 1975 at the same step, so I'll subtract it to the other side. So that's going to give us 2375 over here. We'll divide by 25. And so every download costs 95 cents. So now that we know what the downloads cost, we're going to plug it back into this to figure out what the fee was. So for this, we know the fee equals negative 15 times that 0.95 plus the 1975. So we can just evaluate that, and we should get that the fee is $5.50. Elimination is another one you should remember from Algebra 1. Here we're asked, when you're using elimination, the key is to have one equation, or actually one set of variables. In this case, if you look at the example here, where they have the same coefficient but opposite signs. So when we go to eliminate straight down or add straight down, those two variables should cancel out, and we're then left with only one variable at a time. Then when you solve for the one variable, you can then plug it back in like you would substitution to solve for the other. Sometimes when you're solving with elimination, you do have to manipulate the equations by multiplying by something through the entire equation or multiplying by multiple values through both equations. So here we've got 2x plus 8y equals negative 8, and 5x minus 8y equals 20. This is set up to eliminate. The y should cancel out if I eliminate straight down. So here we've got 3x, this becomes 0, and this becomes 12. We'll divide by 3. X should equal 4. Now that I know what x equals, I'm going to plug it back into one of the equations. I'm going to go back into the top equation. So negative 2 times 4 plus 8y equals negative 8. This is negative 8 plus 8y equals negative 8. I'll add 8. So 8y equals 0. So y has to equal 0. So our solution here is just 4, 0. Sometimes it becomes necessary to multiply one or both of the equations by something in order to create a means to eliminate. You're just creating an equivalent system. You're changing the system's values with what you see, but they're still equivalent to what they were before. So here we have some examples where we're going to continue solving using elimination. The first one we should notice here does not have the same coefficient in both sets of variables, so nothing really cancels out to start with. But if I multiply this top equation by 2, I can change my equation, so now it's 2x minus 2y equals negative 8. Now I can eliminate using these two equations. I've changed the top equation to an equivalent form, and now I can eliminate. So I'm going to add straight down here. I've got 5x. This becomes 0 equals negative 1. I'll divide by 5. X equals negative 1/5. Then to find the other value, I'll just plug it back into one of the equations. I can plug it back into the original if I want to. So like if I want to go back to the very, very original, this one here, I can use that. So negative 1/5 minus y equals negative 4. In this case, I'll add that over. So I've got negative y equals negative 3 4/5. And then divide here, you get y equals 3 4/5. Question 3, very similar. Notice here that nothing matches up, but in this case, you're not going to get by with just multiplying one value. You're going to have to multiply both equations by something. So I'm going to try to get, let's try to get the x's to cancel again. I like canceling out the x's. So I'm going to multiply this top equation by 5 and the bottom equation by negative 3. So now I'm changing both, so I'm just going to go ahead and rewrite them underneath here. So we got one here. This will be 15x plus 35y equals 75. The other one is negative 15x minus 6y. I missed a number here. I was supposed to write 35 over 3y. I just noticed that. So 35y, there we go. 6y equals, in this case, 12. So now we're going to eliminate straight down. The x's cancel. We've got 29y equals 87. We'll divide by 29. And we get y to equal 3. So now that we know what y is, like I said, plug it back into one of the equations. Doesn't matter which one. Let's say we go back here. We're going to go, let's say we did 5x plus 2 times 3 equals negative 4. Oops. Negative 4. So then we get 6. We'll subtract 6 over. That's negative 10. Negative 10 divided by 5. So x is negative 2. Here we're going to solve systems without unique solutions. So let's just take a look at what this means. So here, this is set up to eliminate perfectly. So we're just going to jump right into this. We go to eliminate straight down. We see this becomes 0, and this becomes 0. And so at this point, we've lost our variables. We also have a value on the one side, but notice that this value here, or this statement, is true. 0 is always equal to 0. So it's not no solution. Instead, it's infinitely many. And keep in mind, if it's infinitely many solutions, we can also say that this is independent. Or sorry, dependent, not independent. Ooh, almost messed that up. Dependent. Dependent. All right, so the next one over. Notice here we've got some things that cancel out through elimination. So these cancel out, we get 0, 0, but this time we get 16. So now we have to ask ourselves, is 0 equal to 16? No, that's never true. So this has no solution. And because it's no solutions, that tells us right off the bat that this is inconsistent. All right, here we're looking at some more. In this case, these ones require a little bit extra work, but if you look at this first one, C, if I multiply this equation by 2, things should start to eliminate for me pretty well. You could use substitution, but I like elimination, so I'm using elimination here. So negative 2x plus 2y equals negative 4. Eliminate down, we've got 0 equals negative 4. Well, that's not true, so no solutions. And remember, that means it's inconsistent. And then last but not least, we've got this problem here. Things aren't going to cancel out right away for us, but let's try this one with substitution instead. So here I'm going to change this problem so that way I can substitute y's values back in. So that means I'm going to solve it for y. So that means to solve this for y, I've got to move the 4x over. So y equals negative 4x plus 6. I'm going to take this and plug it in for y here. So that gets us 12x plus 3 times negative 4x plus 18. Or not plus 18, I'm skipping a step. Plus 6, there we go, equals 18. All right, so now we continue solving this. We're going to distribute. So 12x minus 12x plus 18 equals 18. Notice here that these should cancel, and we're left with 18 equals 18. Well, that's true. So this has infinitely many solutions.